Hello students, myself Dattaraj Chopde and I welcome you to this video on detonation in SI engine and its effects. So let's start the video. So first of all, what is detonation? You can see this diagram. There are the four diagrams A, B, C and D. In the normal combustion as shown in this figure A, after the flame is initiated by the spark, the flame front travels with a fairly uniform speed across the combustion chamber, compressing the unburned gas ahead of it. The gas ahead of the flame front is called as end gas. This is the last part of the charge to be burned. The end gas receives heat due to compression by expanding the burned gases and by radiation from the advancing flame front. If the temperature and the pressure are below certain critical values, the flame front moves across the combustion chamber through the unburned charge to the farthest point of the chamber in the normal manner, thus burning the mixture completely. The pressure and crank angle diagram is a smooth curve as shown in the figure B. We can see in this figure B, the pressure and crank angle diagram has no deviations. It is a smooth curve. Now, if the temperature and pressure at the end gas are high enough, it will ignite spontaneously before the flame front reaches it. Under the abnormal conditions, the earlier stages of the combustion are normal, but towards the end of the compression, namely about the last 25% of the flame travel distance, a sudden inflammation of the remaining portion of the end gas occurs. Hence, the end gas said to be auto-ignited as shown in figure C. In the figure C, we can see that dotted portion, which is named as end gas, is burning instantaneously. In auto ignition, the charge must remain above a certain critical temperature for a certain length of the time. During this period, certain chemical reactions take place which prepare the charge for auto ignition. The time required for this preparation phase is called as ignition delay or delay period. In auto ignition, the rate of reaction is very high and the burning is almost instantaneous, which results in extremely rapid release of the energy, causing pressure fluctuations as shown in figure D. In figure D, we can see that there are the fluctuations in the pressure in the P theta diagram. The pressure rise for most of the charge is around 50 bar, but because of the auto ignition, the pressure of the last part of the charge goes to 150 to 200 bar. This large pressure difference gives rise to severe pressure waves which strike the cylinder wall and set it to vibrate, giving rise to a characteristic high-pitched metallic ringing sound. This phenomenon is therefore known as knocking or detonation. The flame speed during the detonation is of the order of 300 to 1000 meter per second. It may be noted that the knocking in diesel engines is a different phenomenon. Knocking or detonation in spark ignition engine always occur near the end of the combustion, whereas in the diesel engine it occurs in the beginning of the combustion. Knocking or detonation is a characteristic audible noise which is transmitted through the engine structure because of the spontaneous auto ignition of the portion of the end gas ahead of the propagating flame. When this abnormal combustion takes place, a very high local pressure, far in the excess of the average pressure in the cylinder, and the pressure waves of substantial amplitude across the combustion chambers are created. A ringing metallic sound clearly indicates detonation caused by the shock waves formed in the gases and repeatedly reflected from the walls of the combustion chamber. The frequency of these pressure oscillation in is the same as the fundamental frequency of the audible knocks. It depends on the velocity of the shock waves and their path between the consecutive reflections from the wall. Intensive detonation causes loud knocks with a higher frequency that arises in each cycle. The power of the engine drops and the black smoke appears intermittently in the exhaust gases. It causes the mechanical damage to the engine. Hence, we will study the effects of this detonation on the engine, which we have stated just now, like mechanical damage, black smoke, in detail. The first effect is the increasing noise and vibration. A violent pressure rise initiates a wave at the point of detonation, which is reflected back and forth across the combustion chamber, causing the audible knock. The pitch of this sound depends upon the size and shape of the combustion space and the velocity of the wave, which is propagated at the speed of the sound in the cylinder gases. A knocking engine thus produces a loud and pulsating noise, annoying the human ears, and is very objectionable in the automobile engines. Detonations also causes the vibration of the engine parts. The next is the increase in heat transfer. Detonation increases the rate of heat transfer to the combustion chamber walls. The increase in the rate of heat transfer is because of the higher temperature of the gas in the detonation engine due to rapid completion of the combustion. Under detonation conditions, the pressure waves score away the protective layer of the inactive stagnant gas on the cylinder walls, and this increases the rate of the heat transfer. The increased heat transfer is responsible for the damage of the engine. The next one is it causes the mechanical damage to the engine. The extremely rapid combustion increases the impact pressure, causing the fractures of the aluminum alloy pistons, and also increases the temperature, causing overheating and burning of the gaskets between the cylinder and its head. Electrodes and insulator of the spark plug, piston crowns, and the heads of the valves. In severe cases of the detonation, increased cylinder and piston temperature cause collapsing of the piston crowns and sometimes burning of the cylinder head. Prolonged running of the engine under detonating conditions causes loosening of the valve insert rings in the cylinder head, burning of the sides of the piston due to blow-by of very hot gases, and gumming of the piston rings in their grooves. The next one is the pre-ignition. So ignition of the mixture by some hot surface within the combustion space before the normal spark ignition occurs is called as pre-ignition. The detonation waves crossing and recrossing the cylinder causes a flow of the hot gases in and out of the spark plug cavity. The hot gases greatly increase the amount of heat picked up by the spark plug. Overheating of the spark plug may be to such an extent that the plug electrodes may become incandescent and ignite the fresh charge long before the ignition is supposed to occur. Thus, overheating of the spark plug electrodes due to the effects of detonation can lead to pre-ignition. The next one is the reduced power and efficiency. One of the principal detrimental effects of detonation is that of the reduced power output. It is because of the fact that the detonation is associated with the increase in the heat losses to the cylinder walls and pistons. It also results in the loss of the thermal efficiency. The next is the more carbon in the exhaust. Over a long period of running the engine, a large amount of carbon gets deposited in the combustion chamber. As a result of the violent pressure fluctuations under the detonation, some of the deposited carbon is not only blown out of the exhaust but also leaves the surface of the combustion chamber, and the top of the piston becomes rough and pitted. So this is from the effects of the detonation. Thank you for watching. You can see more videos like this on the departmental YouTube channel Mechanical Engineering JHRIM Jalga. Thank you.